Okay, so first off, just in case some of you did not hear, tomorrow, Thursday, we will have a quiz on your perfect squares.
Wait, we have you tomorrow?
Yeah, Thursday.
Wait, tomorrow's Monday?
1 to 20.
Tomorrow's Saturday, right?
Okay, so that quiz will be tomorrow. The rest of you need to put your iPads away, please. Yes, ma'am. No, you can I'll just put it up on the board. You don't have to view it. It's okay. Unfortunately, it's too much of a temptation for some people. So all iPads away off your desk. All iPads away and off your desk. Okay. So first off, the assignment said to simplify and to leave your answer in radical form. So that means I don't want decimal answers. If you give me decimal answers, I know you just plugged it into your calculator, and that's not what we're doing, right? So how do we start this? Find two numbers that multiply to equals 1,728. Any ideas? Right, so I know 40 times 40 is 1,600, so I know it's more than 40. Let's try 45. Right, that's too high. 42. 42 gives me, 42 times 42 gives me 1,764. Right, 41 times 41 gives me 1,681. So it's somewhere in between, right? But we don't want decimal. So what do we do? Okay. Let me start fresh then. What we're going to do is we're going to factor this 1,728. Okay. Now it's an even number, so I know it's divisible by what? If it's even, 2, right? So 1,728 divided by 2, 864. Okay. So we're just going to factor it all the way down to its prime numbers. Okay. So 864 is also even. So if I divide that by 2, I get 2 times 432. Don't forget, keep bringing your other numbers down, right? We're making a factor tree. 432, we're going to divide that by 2. So 2 times 216. Okay. And we're going to keep on going. 2 times 108. 2 times 54. Okay. And then we've got 2 times 27. Right? This is a long way of doing it, but it will work every single time. You don't have to worry about whether or not you know what perfect squares go into it. Okay, 27 is 3 times 9. Okay, this is my factor tree, and then I've got one more to go. 9 is 3 times 3. Okay, so there's my factor tree. How many 2's do I have? 1, 2, 3, 4, 5, 6 2's and 3 9's. So I'm going to rewrite this as the square root of 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3 Does everybody understand how I did that and why I did that? Yes.
There's a lot more to it. Like you put like the 2 to like to whatever. How much
We can. I don't want to jump to that right now because that'll be confusing for some. Yes.
Oh, so we're not putting them in pairs right now? 'Cause that's
We
what
are
it is.
now, yes. Now that we factored it out, excuse me, now that we factored it all the way down, now we're going to go back. Because this is a square root, there's an assumed 2 right here, which means I need pairs or groups of 2. So I've got a pair here, so that comes outside. I've got another pair here, that comes outside. And when it comes outside, it's like they get married, they become 1. Okay? They come outside the square root and they become 1. Here's another pair. That becomes 1. Here's another pair. That becomes 1. So every time we see a group of 2 or a pair, it comes out of the radical. And when it comes out of the radical, it's right. Weddings are on my brain, right? When it comes out of the radical, they get married and they become 1. Okay? So what's left inside the radical? Just the 3. So this is 2 times 2 times 2 times 3, which is 24, right? 24. Okay? There are quicker ways of doing it. Okay? For instance, if you had recognized that the square root of 1,728 is equal to the square root of, let's see, 576 times 3, that would be quicker because the square root of 576 is 24. Okay, but then again, right, we could keep playing around with this, all right? So let me just show you other ways that this could be done, right? We factored it all the way down to its prime numbers. Well, sometimes you don't have to go all the way down to the prime number. For instance, I just divided it by 16, and it comes out to be 16 times 108. So I picked a perfect square and tried it, right? So I found, oh, it does get, the 16 does go into that. And what's the square root of 16? 4. Okay, so now let's work on the square root of 108. Well, let's see. Does 4 go into 108? Yes, it does. So I could write this as 4 times 27. Now, what's the square root of 4? 2. So bring that 2 out. And now I've got 27 inside. Okay, so I could keep working it like this. 27 is 3 times 9. I know the square root of 9 is 3. So 8 times 3, which is 24, square root of 3. Okay, so sometimes you don't have to go all the way down to the prime numbers, but that will work every time if you're not good at the perfect squares. Okay, but what I usually do is I sit there with my calculator and I just start trying it. Okay, so I'll show you with my calculator. Okay, so what I will do is okay, let me take 1,728. Let's divide that by 2. Okay, I know it divides by 2. Okay, let me try it by 4. So I'm going to go through my perfect squares. Okay, 4 works. Let me try, let me try 9. Okay, 9 works. And I'm going to keep trying my perfect squares. 16 works. Okay, let's try 25. 25 is not going to work. And the reason I know it doesn't work is because I just got a decimal point. Okay, so I know that 25 did not work. Okay, so I'm just going to keep going. If I divide it by 24, well, that's nice, right? I get 24, so I could do 24 times 72 and then break that down. Okay, let's do that. If I got the square root of 24, okay, please pay attention because when I asked you guys how to do this, nobody answered me. Nobody knew how to do it, so please pay attention, right, D'Angelo? Please pay attention. Okay, I just played with my calculator and I got 24 times 7. I'm just looking for pairs. It doesn't have to be all the way down to the prime number. Well, 27, that's 3 times 8. And 72 is 8 times 9. Well, there's a pair right there. So I can take that pair out. And what's left inside, I have 3 times 9. What's the square root of 9? 3. So we get 8 times 3, square root of 3. So that's 24, square root of 3. Okay. Okay, let's do another one. Let's do number 2, 1,872. Right? Square root of 1,872. Now, just like the previous one, if I factored this all the way down to the prime numbers, that's a lot. That takes a long time, right? So let's see if we can find something that goes into this, 1,872. Let's try 24. Okay, that works. 24 times 78. So this is the square root of 24 times 78. Okay, now let's factor these down. Okay, 78, I know that is what? 39 times 2. And 39 is 3 times 13. Okay, and 24 is 3 times 8. Right, and then we've got 3, and then 8 is 4 times 2. Okay, so let's rewrite what we have. We have the square root of 3 times 4 times 2 times 3 times 13 times 2.
Can you break the 4 down?
Okay, we will. Yep. Okay, look at pairs. I've got a 3 and I've got a 3. So that's a pair. That comes out. So we're going to bring that outside. And then I've got a 2 and a 2. So that's going to come off. So now we have 4 times 13 inside. So we have 6 times the square root of 4 times 13. What's the square root of 4? 2. So this is 6 times 2 times the square root of 13, which gives me 12 square root of 13. And that's our answer. Yes?
Why don't you just factor the 4, 2, and 2?
We could. We just didn't have to. Because I know the square root of 4. So if I know it's a perfect square, I don't have to keep factoring it down because I know I can take the square root of it. Okay, let's do another one. Let's do the square root of 784. Okay. So what do we do first? Sam, what do we do? How do I do that? Okay, I want to see everybody with their notebooks out taking notes. Open your notebooks. I want you taking notes. Okay, so if I go in my calculator and I do the square root of 784, okay, so is that good? 28. That's a nice one, right? That's nice and easy. So we're good. That one's 28. By the way, if I look at your homework, am I going to see a bunch of decimal points in the answers? Okay, good job. Okay, let's do the square root of 192. So let's check that on our calculator. Square root of 192. Is that going to come out as a whole number? No. Okay, so square root of 192 is not a whole number. So how do we figure this one out, Patrick? Okay, two numbers that multiply to equal 192. All right, so let's do 192 divided by, let's try 16. Okay, and honestly, I know it's divisible by 2, so I'm just trying a larger even number. Okay, so it is divisible by 16. So I've got, this is equal to the square root of 16 times 12. Okay, Angel, where can I go with that?
Like keep going down.
Okay, as a factor tree? I can. Can I take a shortcut anywhere? Do you see anything I can take a shortcut with? Nico, you see any place I can take a shortcut? No, that would just bring me right back to 192. Ava? Yeah, we know the square root is 16, right? That's why I'm making you memorize those perfect squares, so that you'll recognize this. What's the square root of 16? 4. So we get 4 times the square root of 12. Okay. Now let's do what Angel said, and let's factor this down. 12 is 3 times 4. Again, I could continue to factor it, but what do you notice? We know the square root of 4. So this is equal to 4 times, what's the square root of 4? 2 times the square root of 3. So we get 8 times the square root of 3. Okay. Questions, Ethan? 192 is 16 times 12. The square root of 16 is 4. So we have 4 times the square root of 12. Okay. Okay, let's look at another one. Let's look at the square root of 160. So if I do that on my calculator, square root of 160, I get a decimal again. So I can't just do that. So what do I do? Factor it down. Yeah, we can try 8, right? It's going to be 8 times 20. Or 16 times 10, right? That's going to be even better. Why is 16 times 10 better than 8 times 20? Because 16 is a perfect square, right? 8 times 20, that'll work. But I'm going to have to do more work because neither one of these are a perfect square. If I can factor it using a perfect square, it makes it easier. So the square root of 16 is what? 4. So now I have the square root of 10. Okay. So let's factor that 10 down. We're looking for pairs. 10 is 2 times 5. Can't go anymore because they're both prime numbers. And there's no pair there. So the 10 stays inside the radical. So it's 4 square root of 10. Okay. Okay, square root of 864. Okay, let's check that on our calculator. The square root of 864. And that is not a perfect square either. So we're going to rewrite it. Let's see, what do you want to try? I want to try 16 again? 864 divided by 16. 54. Okay, so what's another one?
24.
Yeah, but 24 is not a perfect square. Okay, so we got 16 times 54. We could do 24, by the way, Rod. That would be okay. It's just a little bit more work because it's not a perfect square. Okay, so now we have the square root of 16. So what do we do with that? Take it outside. Okay. is the square root of 54.
Let me factor them.
Yeah, let's factor down that 54. So we know 54 can be written as 9 times 6. 9 times 6. And I can stop there because 9 is a perfect square. So this is going to be 4 times the square root of 9 times 6. Take the square root of the 9 out, so 4. Now, everything that comes outside, they all get multiplied together. Okay, and that leaves me with 6 inside. So that's 12 square root of 6. Now 6 is 2 times 3, so I don't have any pairs there. So we just leave the 6 inside the square root. Is this starting to make sense? Refreshing your memory? Okay. Okay, how about the square root of 1,215? Okay, first we're going to check to see if it is a perfect square. So we'll take the square root of 1,215. And it's not a perfect square because I got decimals there. So what do you want to try dividing it by? 15? Okay, we could. Yep, let's try 15. That worked out nice because why? 81's a perfect square, yes. So that worked out really nice. So this is the square root of 15 times 81. Bring the perfect square to the outside, and what does that equal? 9. Square root of 15. And 15 is 5 times 3, so we don't go anywhere with that. So we leave our answer as 9 square root 15. Okay. Okay, let's look at more. Square root of 1,400. Now this one, it's like you feel like it should be a perfect square, but it's not. Square root of 1,400. And some of you are going to say, oh, that's 70. No. Square root of 4,900 is 70. Okay, so we know 100 is going to go into it, right? So we can rewrite this as 100 times what? 14. And where do we go from there?
It's 10.
Square root of 100 is 10. Good. Times 14. And 14 is 7 times 2. So that's not going to help us. So we just leave it as 10 square root of 14. Okay. Square root of 2,028. Okay. Check and see if it is a perfect square. And it is not. Okay. So what do you want to try? Let's try 16 again. 2,028 divided by 16. That doesn't go evenly. Okay, let's try 4. 2,028 divided by 4. Okay, that goes evenly. So we've got square root of 4 times 507. We know the square root of 4 is 2. Okay, now we have to work on that 507. So let's see. Let's do 507 divided by 3. That worked out really nice. Okay. Why did I choose 3, by the way? Well, it ends in 7, right? So I'm trying to think of what type of numbers could I get 7 in that one's place, right? So 3 would give me 7 if I did 3 times 9. That's 27, right? 9 would give me 7. 7 would give me 7, right? So I'm thinking of numbers that I could multiply by something and get a 7 in there. So the numbers that came to my mind were 3, 7, and 9. So I started with 3. Okay. And that worked out nice because 169 is a perfect square. Okay, so this is going to be 2 times the square root of 3 times 169. Now, what's the square root of 169? 13, good job. 2 times 13 times the square root of 3 gives me 26 square root of 3. Okay. Okay. Let's do the square root of 216. Is that a perfect square? Boy, it sounds like it, but is it? No, it is not. Okay. So what do we want to try? 216. It ends in 6, so we're looking at 2, 3, 4. Try 3, he said? Okay, 3 times 72. Okay, that's a good start. So this is the square root of 3 times 72. Neither one of those are perfect squares yet. So how about 72? That's 9 times 8. All right, so we've got the square root of 3 times 9 times 8. Well, do we know the square root of any of those numbers? The 9. Right, so we'll take that out. That's 3. Is the square root of 3 times 8. So then what? 8 is 4 times 2, right? So we've got 3 square root of 3 times 4 times 2. So we can take the square root of 4 out. 3 times 2 outside. 3 times 2 inside. So that gives me 6 square root of 6. Okay. I'm going to show you one of the ways that I check my answer. Right? In order for this 6 to be outside, it had to be 6 times 6 on the inside. Do you all agree with that? So what I do is I just double check it. 6 times 6 times whatever's left inside. So 6 times 6, that's what's outside, times the 6 that's inside, and sure enough, that gives me 216. Okay. Okay. Next, oh, here we go. Square root of 1,575. I'm going to give you a second to do this yourself. Okay, let's do this together. So 1575. So that is not a perfect square, right? The square root of 1575. Thank you. Okay, square root of 1575 comes out to a decimal. But since it ends in that 75, I am pretty certain that that is divisible by 25.
Yes.
Okay. So there we get 25 times 63.
You can do 70.
Okay, it's okay if you did more. That's okay. It's okay if you did more. Right. So, square root of 25 is 5. Now we're going to work on the 63. And I know that 63 is 9 times 7.
Take the square root.
And the square root of 9 is 3. So that's correct. You can take out more. Yep. So I've got 5 times 3 times the square root of 7, which gives me 15 times the square root of 7. Yes, ma'am?
Did you try it with 45 times 35.
45 times 35 will absolutely work.
Yeah.
This is how I can tell you that without even using my calculator, right? Because 45 times 35, right? I know that 45 is 9 times 5, and 35 is 5 times 7. So these 5s are going to come out, and then the square root of 9 will come out. So I'll have 5 times 3, leaving me with 7 inside.
So if you get two numbers like 5 times 5, you take it out, you put 1.
Yes, because they get married. Yep. So that's why in the beginning, the first one we did, that's why I did it that way. Worst comes to worst, you can just factor it all the way down. Just keep factoring it and then pull out the pairs. Here's a pair, they come out as 1. Here's another pair, it comes out as 1. There's another pair, it comes out as 1. And here's another pair, and it comes out as 1, leaving me with just that inside. So I've got 2 times 2 times 2 is 8, times 3 is 24, square root of 3. Okay, so worst comes to worst, just factor it all the way down to the prime numbers. But that takes longer. So if we can stop somewhere in between, that makes it a little easier for us. Okay. Okay, let's see here. Let's look at another one. Got to make sure we get this before we move on. Okay. Square root of 224. Is that a perfect square? I know the square root of 256 is 16. So what about 15? That's 225, right. So 224 is not a perfect square. So what do you want to try dividing this by? 4? Okay, 4 sounds like it might work. 4 times 56. Could I have done anything else? Maybe 16? Yeah, let's try 16. Good. So once I find a perfect, something that divides, I try to go bigger and I try to use a number that is a perfect square. Like I didn't try 8 because 8's not a perfect square. So I wanted to try 16 first and see if that worked. Okay, and sure enough, it did. Okay, so we've got 16 times 14. And the square root of 16 is 4. 14 is 2 times 7, so that's not going to factor down. That's going to just stay as 14. So there's our answer. Okay, the next one's a big one. Big one, really big one. Square root of 2,744. Square root of 2,744. I always check to see if it's a perfect square before I start. Whoops. Okay, and it's not. Okay. So let's see. 2,744. Gee whiz. Let's try 44. Well, that's not a perfect square, is it? It's not going to work anyway. 2,744. Okay, let's try 24. Yeah.
14. Wow.
Did you really?
Yeah, I got the same thing though.
How about 16? No?
14.
14?
Yeah.
Okay, 196. Oh, I like that. I'm liking 196.
Perfect square.
There you go. 14 times 196. You see how knowing those perfect squares is so helpful, right? So the square root of 196 is 14.
14.
And we're left with 14, square root of 14. Okay? 2 more. So
this
we're,
is the same thing as the worksheet we did when you were gone, right?
yes, this is the worksheet we did when you were gone, when I was gone. Okay.
So much easier.
When you see it the second time, it's always going to be easier. Square. Oh, did you?
We factored out the whole thing. Yeah, we did a long factor.
I teach it that way to my Algebra 1 class. But you guys are smarter. So my Algebra 1 class, we factor it all the way down like I did the first problem. Oops, which is gone. Right. No, you can do it the way we're doing it. So my Algebra 1 class, we do it that way, and I call it my Tutron train. And we take all the pairs off the train, and, there's a whole thing, and I run through the room going, choo-choo, But you guys are too mature for that, so we don't do the choo-choo thing, right? So that's fine. That method is perfectly fine, and that's how I teach it at the lower grade levels. Okay, square root of 847, is that a perfect square? No, that's not a perfect square. But if you're not sure, let's do it. No, okay? So let's see, 847. Let's try dividing that by 9. Again, because it ends in 7. Does not work. How about divided by 3? How about 7? Okay, 7 worked, and that's a nice number. Square root of 7 times 121. Square root of 121 is 11. And we're done. So this is easy when I do it because I'm pretty good with numbers, right? This is one of those things that when you go to do it, you're going to sit there like, what in the world? Banging your head. How come it's not working? I understood it, right? You have to think. I'm just not randomly plugging in numbers, right? I'm thinking about which numbers I'm trying because I'm looking at that last digit, okay? Some basic rules. If it ends in an even number, it's going to be divisible by 2. So then I work my way up, trying to find the biggest number I can take out. 2, 4, 8, 10, and I'll keep doing that, all right? If it ends in 5 or 0, what's it going to be divisible by? 5. If it ends in 0, what's it divisible by? 10, okay? If it ends in 1, I try 3, I try 7, I try 9. If it ends in 7, I try 3, 7, 9. Okay? So there's some rules there that I use. You just have to think a little bit. Okay, the last one we're going to do. We're looking at the square root of 484. Okay? Is that a perfect square?
Yep.
Good for you for checking it first. Way to go. 22. Excellent. Okay. That's a perfect square. Okay. Okay. Yes. No, because we took it. Yeah. When the train is empty, it disappears. Okay. Nobody's on the train, it disappears. Okay. Okay. Questions about this? All right, let me give you one to try by yourself here. I'm going to give you a really hard one. Square root of 4,056. Okay, so 4,056. So let's see if it's a perfect square. And it is not. Okay, so it ends in 56. So I'm going to try 4 first. And it is divisible by 4, but let's see if we can go bigger because that's a pretty big number. So let me try 16. 16 does not work. So let's try
24, 26.
Okay, 13 times 312. Let's write that. Let's see what that does.
Oh, yeah.
13 times 312. Did I do that right? 4,056.
Because you saw this.
Okay, so let's do 312 now. 312 divided by 4. Okay. 312 divided by 8. All right. 312 divided by 24. The reason I'm choosing 24 is that it's 8. Yeah, when I divide by 8, I get 39. Well, 39 factors down to 3 times 13. So I did 8 times 3. So that's going to be 24 times 13. So I've got the square root of 13. And when I factored the 312, I got 13 times, was it 24? Okay. So I'm going to take the 13s out because there's a pair. And I have 24 left. Well, 24, that can factor down to 4 times 6. I chose 4 times 6 instead of 3 times 8. Why did I choose 4 times 6? Because 4 is a perfect square, right? I'm looking for those perfect squares. So that brings the square root of 4 is 2. So I end up with 13 times 2, which is 26 times the square root of 6. Okay?
I did 24 times 169.
That's fine. Yeah, because you're going to get your 4 times 6 and your 13. Yeah. Okay. And hey, worst comes to worst, we sit there and we go, okay, 2 times 2028, 2 times 1014, 2 times 507, okay? And we keep going. So that's the worst case scenario. And then we grab our pairs, right? 507 should be divisible by 3. That's 3 times 169. Okay. And then 169 is 13 times 13. So if I look at what I have here, I have 2, 2, 2, 3, 13, 13. Did I miss another 2 somewhere? 2 times, I feel like I did. Okay, so this is going to be the square root of 2 times 2 times 2 times 3 times 13 times 13. Okay, so this is the method that you were taught earlier this week. Factor it all the way down to the prime numbers, right? It's even, so I started with 2. 2028 is even, so I divided by 2. 1014 is even, so I divided by 2. Now I'm left with an odd number, so I start with 3. Okay, factor it all the way down to its prime numbers, and now take your pairs out. There's a pair, so that 2 comes out. There's no pair here, so he stays on the train. He doesn't have a friend. The 3, that doesn't have a friend. It stays on the train. Here I have a pair, so that comes off the train. Right, so what's left inside? 2 times 3. Outside, we have 26. Inside, we have 6. Okay, so that's the other method. Okay, you can play around with it and see if you can find perfect squares, or factor it down to the prime numbers and then grab the pairs and bring them off the train. Okay, questions? Okay, we're going to stop there today. When do we have class again? Tomorrow. Tomorrow we have our quiz on the perfect squares, and then we're also going to start on taking square roots that have variables in there. Okay?